So how are we doing there? Any leftover questions from the last? I'm hoping the last class, if you were here, that kind of helped to firm up some of the ideas. Right, so it's, chapter 6 is like the groundwork for everything left. So it's a little important. I can't stress the importance enough. So chapter 7 is where we start to, it's nothing new. It's just combining all this stuff together into one cohesive thing. So let's see what the hell I mean. So we have several ideas to put together here. If I have a normal distribution, and in fact they kind of generalize this for almost anything, what would unusual be defined as? What would be unusual?
Further than 2 standard deviations.
Beautiful. So further than 2 standard deviations. So outside of here would be considered unusual. So above 2 or below -2, Z-score would be officially considered unusual. And that kind of goes into the fact that how much stuff would be out there if it was normal. What percentage of stuff would be out there?
5%.
Because what percentage of stuff is in the middle?
95%.
95%, so there must be 5% outside. Beautiful. All right. That kind of all goes together. If there's only a 5% chance of something happening out here, then I would say that that's kind of rare. That's unusual. How we doing so far? Okay, good. Then there's this idea that kind of captures this. So that just really says the same thing, but more in formulaic form. So this is start at the mean and go up or down 2 standard deviations, right? To kind of capture 95% of the data. Anything outside of there is unusual. So really what I want to do is, what do we always want to do in statistics? We're finally getting to the point where we can do real hard statistics, which is, what the hell do we want to do in statistics? What do we normally do in statistics? If I want to know the percentage of students at Grossmont who smoke, what would we go do? Take a sample. You could watch. You could either have a sample that you watch, and then you tag them. Right? You do a little mark on their shoe like they do on your car tire. I counted you. Right? Who the hell was that? Or you could talk to people, ask them. You always run into the possibility they'll lie, but smoking is not, unfortunately, not completely not accepted anymore. I'm letting my views get into the way. So I could either observe, I could take a sample directly by surveying people, but either way I'm going to get a sample. Anything I find from that sample, is that the absolute truth? Obviously not. It's just a freaking sample. So the part that we haven't really fully done yet is go from the sample to something that I can say in general. I can't, from the sample I could say, well, 98% of the people I talk to do this or whatever, but I can't say 98% of everybody does that. I can't make that step. So I want to show you something on one of my favorite stats websites. There you go. While that's warming up, we're going to look at something else here. So let's get into this a little bit, because I do want to show you this, just to show you that we're going to be able to calculate some stuff that we see. In fact, let me ask you this. I don't need to show you this. Whenever they show on the screen, like whenever before an election, they always call somebody. It's never me. I don't know if you've ever been called and asked questions. We're taking a survey. It's never been me. I don't know. They must know stats people and just say, let's not call him. And then on the screen, in the newspaper, on the TV, you'll see person A, 42% want to vote for him. Person B, 48% want to vote for him. Right? You guys kind of. What do you always see at the bottom of the screen?
Where it's from.
No. So I see like Obama, 47%, Romney, 48%, and at the bottom you'll see something that seems to be trying to cover their ass.
Paid for by Obama administration?
I like that. What was the last part?
When they do the ExxonMobil things about the environment and how much they care, because they get gas company.
Oh yeah, true. I love it. Yeah, we obviously care about the environment because we're saying we do. Yeah.
They usually talk about the sample that was taken.
Unfortunately, not. Normally, not. But what you always do see is plus or minus 3, or actually most often 4%. Right? Which kind of makes sense. I mean, that number right there? Have you guys, anybody ever noticed that? Or is it just me? You guys have never noticed that? Shit. Read a newspaper. If you don't like the ink, just put gloves on. I don't know. It's weird. Read my newspaper with gloves. I don't know. Kindle. You can get newspapers on Kindle. But you always see that at the bottom. You see, give or take 4%. So on one level, it makes sense. Because where did they get these numbers from? Did they talk to everybody? No, they talked to us. Shit. And at least some of us voted. Right? Hopefully. So where is that coming from? The idea of it makes sense. Why would that be there? Because is this right? No. So they're like, give or take 4%. But did they just go, give or take 4%, 5%, what the hell? We're going to see today exactly where that number comes from that unfortunately none of you ever knew was there. It would have been nicer if you guys had actually seen that before, but too bad for me. Let me show you this on the Gallup website. Someday I'll show it to you. So real quick, while that piece is warming up, we also, the more general way to look at this was this formula here. You guys remember this formula? This was x equals. You guys kind of with me? So this would be, I start at the mean, I go up and down. Now, the up and down part would be for a specific application like this. The 2 in this case makes sense because it just takes the place of the Z-score. That's the number of standard deviations that I want to go out. And if I go 2 steps out, I'm going to catch 95% of my data. So if I'm looking for a specific value in here, how certain am I that I caught it? How confident am I that I would catch a certain value? 95%. Because I catch 95% of the data. So if I catch 95% of the fish in a lake, number one, everybody else about to put their boat in hates me. But number two, I am 95% certain that I caught a certain fish that I wanted to catch. Right? There's only a 5% chance that I didn't get it. Because there's only 5% of the fish I didn't catch. Are you guys kind of with me? So I even though I don't fish, since I was like 7, and then I got seasick there, so I figured I'm not a seagoing type. I love to use the idea of a net. You cast out a net and you catch so much, so you're that certain you caught a specific something. That's the whole idea of this chapter, actually, chapter 7. So look here. Oh, I got so excited for a second. There we go. All right. So go to Gallup. Please, there. Okay. Blah blah. You go to almost anything here. Yes, I probably would lack confidence in elections here. So you go all the way to the bottom. So they talk about all these different things, and they've taken polls, and they get all this data. The beautiful thing about this website is they get very into the methods, survey methods. Now let me zoom in on this. All right, so let's take a look at this. So results are based on face-to-face interviews. Beautiful. So you take out the possibility of somebody not having a phone, because that's probably more likely. It is still likely here. Based on face-to-face interviews, 1,000 adults, 15 and older, blah, 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 blah. For results based on the total sample of national laws, one can say with 95% confidence that the maximum error is plus or minus almost 4%. So it's like give or take. So for all the data they report, all the percentages they give up here. So up here you see 70% don't have confidence in the election. Right? You see that? 70%. So it's really somewhere between about 66% and 74%, give or take, because of the fact that it's based on a sample. So they have to cover their ass somehow for the fact that the population is probably different. Now, what do you think that plus or minus 4% is based on? What's one way I can make that number get smaller so they get closer to the real number? Beautiful. The quickest way to do it is to take a larger sample. In fact, to make it go to 0, I just take everybody. And then I'm super confident because I'm looking at every freaking person, right? But most of the time that's not possible. Either you don't have time or you can't get to everybody or whatever. How are we doing so far? Is this... So some of it sounds like old stuff. You've already talked about some of this stuff, which is beautiful. This is kind of repackaging old stuff into one beautiful little thing that we can create. And we're going to, at the end of today, we could probably redo, if they gave us the hard data, we could redo this. We could find out where that came from. That give or take. All right. Maybe. Now, it's funny you said that earlier that you see this, most of the time you do not see this on websites and these things called newspapers. You don't see, who they talk to, how many people they talk to, what the error is, right? Okay. Maybe. All right, so let's do this. If I'm you, I'm like, please, dear God, get a little more concrete now. So what does this mean for you in terms of the work you're going to have to do? So we have this formula here. Let me focus on this piece of it. So, normally in statistics, do I know this? When I have something I'm curious about, do I know this? What is this? The mean of population. So do I normally know that going in?
Yeah.
All right, so you guys are used to knowing it because we're in a manufactured environment, right? But if you said, man, I wonder what the average gas price right now is in Hawaii. Do you know what it is? No. In fact, you can't even look it up because gas prices are changing constantly, all the stations. Yeah. So the best you could do is go to Hawaii. Sounds like a great field trip, but it ain't happening. Go to Hawaii and do what?
Record the price of the gas.
Yeah, take a sample of gas stations. Or I could say, let's say something a little larger than Hawaii. Let's say Texas. Do you want to record all the prices at every gas station in Texas?
No.
Probably not. So what would I rather do? Take a sample. The minute I take a sample, will I ever actually get that? No. What will I get?
The mean sample.
Sample mean, which is what as a symbol? X bar. So I have to replace this with X bar. Now what else has to change because we're taking a sample? Beautiful. Standard deviation's got to change. So this has got to become what? Beautiful, I love it. Standard deviation divided by square root of n. Does that sound familiar?
Yeah.
Hopefully. Just pretend it does if it doesn't. It'll make you feel better. Alright. And now what we're really doing is we're saying, if I find a sample mean, I want to do like Gallup did. I want to say, give or take how much. And it's not going to be a percentage for this. We're going to do section 7.2 is about percentages. Section 7.3 is about means. So we're actually going to start with 7.3 because it builds off of formulas we know. 7.2 is a formula we don't know yet. So it makes more sense to start with 7.3. What I want to do is say, here's my sample mean. How far up and down do I have to go to be able to tell somebody I'm 95% confident that the real mean is in here?
3.
So we're going to get a sample mean. I'm pretty confident about that if I take a decent size sample and it's random. Are you with me? If it's a decent size, I didn't just do 2 and got tired, and it's randomly chosen. I didn't just pick ones that were near me. If I do those two things, I feel decent about this, but I still know it's probably not right. So I want to say, how far out do I have to go to be 95% confident that the real price is caught by that interval? So yeah, it would be 2 standard deviations, right? Okay, cool. But the beautiful thing is, I don't know if anybody realizes this, what if I wanted to be more confident? What if I wanted to be 99% confident? Then you have to figure out the z-score that catches 99% of the data. You with me, it wouldn't be 2 anymore. It would be bigger than 2. I have to go further out. I have to throw a wider net out if I want to catch 99% of the freaking fish and really piss the people off. They haven't gotten in the water yet, right? All right, maybe. So what we do is, that's the z-score. This z-score is based on how confident we want to be. If we're cool with being 80% confident, then we would only have to go out that far. Catch 80% of the data. If I want to be 99.9% confident, holy crap, I'm going to have to go out pretty damn far to catch that much of the data. Maybe. And then I'm going to go up and down just like I did here. I got to make an interval around my sample mean to say I'm this confident that that interval caught the real mean. So much like almost everything we do, the explanation and the concepts are more difficult than the actual work, which makes sense. The concept of why something works is more difficult than the actual work. I can turn my damn car on and drive here, but I am horrible at fixing cars. So I have no idea why certain things on it work, right? Which is, and some of you guys are like, well, I actually fix cars, so thank God there are people like you that need to call me. I'm like, all right, there you go. Keep you in business. So this, let me take some of this away. This here, so confidence intervals. This is the formula for the confidence interval of a mean. So just to kind of run through it one more time, and then we'll do an actual concrete example, which is always nice. I have a situation, let's say the mean gas price in Texas. I want to know what that is. And that would represent a parameter, because my population would be all the gas stations in Texas. Are you guys with me? Mm-hmm. So I want to know a parameter. We often can't get the damn parameter because I can't look at everything. So I take a sample and get a sample mean. That's my base, that's my start, it's my best guess. But then I say, okay, give or take so many cents. Then I would be 95% or whatever confident that the real mean, I'm trying to catch the real mean. I'd be 95% confident that this interval I just created would catch the real mean. So there's the real mean is somewhere, maybe it's here. So any interval I make, if I use a 95% confidence and use a z-score of 2, then 95% of the intervals that we make would catch the mean. 5% of them would not. The mean would be out here somewhere. And again, 5% chance of being wrong, I can live with that. It's better than normal for me. Okay, maybe. All right, so now let's do a concrete example. Let's see, let's say you want to know like the average grade I give in stats classes. All right, so you sample, let's say, 50 people who've taken my stats class the last few years. How are we doing so far? So we have some parameter that we want to know. What's the average grade Jeff gives in his stats class? All right, we have a parameter that we want to know. So we go take a sample to get the statistic related to that. How are we doing? Well, there's a lot of vocabulary coming back at us. Parameters of population, statistics sample. All right, so I want to get the statistic from the sample and try to use it to infer something about the parameter that I'm trying to get. So I want to know what the average grade is, my total average grade. Take a sample of 50 kids. I find the average from this sample is 81.9. I think is I can't remember if that's close to right or not. Right, so we take a sample and we find 81.9. Now, 50 is actually a really good sample size. And we have a better feel for why that is because how big of a sample size do we need to ensure that our sampling distribution is normally distributed? 30, I love it. Remember the number 30. That's from the central limit theorem. CLT, not chicken, lettuce, tomato. Yeah.
So more than 30 people should make the...
It makes the
effective?
it makes the distribution of all samples become normal. But that gives us a better feel. Some of you guys would have said 50 is not good enough. Because how many people have I taught statistics to? A lot more than 50, right? I have more than 50 in this classroom right now. And I've been teaching since 1998. So I think I've taught a few more than 50. So some of you guys would have said, no, 50 is not very big. But I really want you to understand, if you randomly select these people for the last few years, then that's a good sample. 50 is damn good size. Gallup almost always uses around 1,000, even though they're trying to talk about America, which has 310 million people in it. So you guys would have went, hey, good enough, you're leaving out so many people. I don't care. If that's randomly selected, in fact, in this case, we weren't talking about America. This was
Afghanistan.
Thank you, Afghanistan. So I don't know the population of Afghanistan off the top of my head, but it is much more than 1,000. But that's a really good sample if you randomly select it. So let's say we got X bar is 81.9. I tell you that the standard deviation for my grades has been 12.13. So say we want to find the 95% confidence interval, or the true mean final grade. Okay, cool. So this is exactly the kind of problem you're going to see. They're going to give you this information. They're going to ask you this question. First thing you have to do, and we know the formula I want to use. So we already know this. We know this. We know this. You're going to have to be given those, or at least a list of numbers that you can calculate the mean from. You with me? You're going to have to be given those things. The only thing you're not going to be given is the Z-score, but where does the Z-score come from?
The chart.
I love it. So if I want to be 95% confident, now let's be a little more specific than 2. It's not exactly 2. We're going to be a lot more specific than 2. It's close to 2. If I want to be 95% confident, that's this. Every confidence interval, and this is why I had that question on the last test. It was getting you ready for this. If you want to catch the middle 95%, that's exactly what we want to do. What are these Z-scores that would do that? So how do you find that?
Track one Z-score.
Yeah, how much is outside?
5%.
5%, so how much is on one side?
0.2.
2.5%. I love it. So if you look up 0.025 in the Z-score chart.
0.25. Oh.
2.5%, yeah, 0.025. If you look that up, yeah, I see some motion. This is good. Because I ain't going to say it until somebody gives me a guess. Careful now.
Is it in the negative?
Is this a Z-score? No, it's a what? Area. Percentage. Where are the percentages in the areas here?
Is it going to be?
And like somebody just said, it's got to be on the negative side, right?
Yep.
Good. Positive side's got these big-ass numbers, bigger than 0.5. It's no good.
Is it a negative 2.8? No.
1.9, 1.96.
Negative. I like. Okay, there.
Negative.
So this one's going to have to be.
Positive 1.96.
I love it. So if I would have said 98% confident, you would have cut that. That would have been 2% outside, 1% on that side. Look up 0.01. You got it. You with me? I can change how confident I want you to be. So that Z-score is going to be dependent on how confident you want to be. How far do you have to go out? If I want to be more confident, I've got to go further out. That almost makes too much sense. Hopefully, it should. If you want to be less confident, you just don't catch as much stuff. Don't go as far out. Yeah.
Why is it not negative 2.81 for 1?
Because you're not looking at point. I don't know. Are you looking at point 0025? It's 0.025.
Yeah, it's
Oh.
yeah.
So it's 025
Yeah.
for 2.5%. Yeah, good.
Yeah.
So now we got everything we need. Now this is what I was saying earlier. The concept is always more difficult than the work. But the concept is still freaking important. Now it's just plug and chug. What's X bar? So I got my formula here. What's X bar? 81.9. What's Z?
1.96.
And do you see how the plus or minus is built in?
Yeah.
Don't put it negative. That doesn't make any sense. The plus and minus is built in. The up and down. So all you really care about is the pure number. What's the standard deviation of the population?
12.13.
12.13?
Yeah.
And you got to divide that by
The population 50.
square root of 50. Cool, man. Now let's do this together so you see how to put it in your calculator.
85.26.
So what I would always do, if you need a calculator up here, make sure that it turns on. I keep forgetting to make sure I put new batteries in some of these. This piece here, incredibly enough, that piece is called the error. Why does it make sense? So what do we find from our sample? It's 81.9. But that's not right. How much could we be off by, give or take that much? That's my error. That's how much I'm saying that it seems this is off by, give or take. So the way that we say it in English only makes sense. It's give or take that. That must be how much we think we're wrong. That's called the error. So what I always do is I calculate the error first, and then I add it and subtract it. Because there is no plus or minus button. Don't look for it. All right? So what I do here then is I just do 1.96 times 12.13 divided by square root of 50. That's my error. You guys got that there?
Yep.
How we doing? Let me put this up here. So I've got 81.9, give or take 3.36 roughly. Pretty much the rule of thumb is you go one more place out here than this is. You guys kind of with me? I'm a little more lenient with that. I don't, as long as you go out far enough, you're okay. But one more place than this is normally acceptable. So then what do you get? 81.9 minus this. 81.9 plus this.
85 the plus I got.
$78.54 for this one.
85.26.
I like it.
Yep.
Cool. All right. So as if this could not get any better, it does get so much better. Because you need to write a statement at the end that I will not correct for grammar necessarily, because I'm not an English teacher, but you do need to write a statement telling me what the hell you just did. So what we got was between 78.54 and 85.26. That's our confidence interval. That's the thing we created around the 81.9. That's the interval we created. So here's how you word the statement. It's a little bit of semantics to be careful about how to say this. The statement would say, we are 95% confident that the interval 78.54 to 85.26 contains the true mean grade in Jeff's stats class. Oh, yeah. Because I know we are all in this class for very different purposes, but I don't care. The basic idea of stats is if you can't explain to me what you just did, it's all worthless, right? Math, you get a number, normally it's good. Sometimes you got to put units down, or else I'd say, 7 bananas? What the hell are you talking about? Statistics, you always have to be able to explain what the hell you just did. What does it mean? Okay, so what's the chances that I'm wrong, that my interval doesn't catch it? 5% chance. And that's, I'd like that. 5% chance I'm wrong, that's good. It's not bad. If that wasn't good enough, so that's basically it. You get the interval, and then you have to give me the statement. If I wanted to be more confident, I only want to have a 1% chance to be wrong. What would change in our work? The Z-score would change. I like it. So, immediately, I want you guys to try this problem here out. Just do part A right now. We still got to talk about part B. Shoot. That doesn't feel right. So when you get this, start working on number 1A on this handout.
Oh. Sorry.